Hello, my name is Dmitry Savelyev. I'm a representative of Samara National Research University and Image Processing System Institute of the Russian Academy of Science. Topic of my report is the investigation of the cylindrically polarized beams focusing by diffractive axicon using high-performance computer systems. What is the axicon? Axicon is an optical element that forms a zero-order bezel beam, the diameter of the central spot of which at the full width at half maximum is 0.36 wavelengths and divided by the numerical aperture. So this is smaller more than 37% than the size of an airy disk formed by a lens with the same numeric aperture. So the axicons are used for forming an extended focal segment with narrow transverse size, even overcoming the diffraction limit. On the slide you can see the complex transmission function, structure of the element, the radial cross sections of the phase element, and the picture of experimental demonstrations on the optical axis with the high numeric aperture binary axicons illuminated by circular polarized beams from one article by the author of this report. The Cartesian components of the electric component of the monochromatic electromagnetic field in the focal region during axicon focusing can be represented in the following form: equation 1. In these equations, I is considered the cylindric components in the focal region, k is the 2p division on lambda, so is the wave number, lambda is the wavelength, f is the focal length, r is the axicon radius, q is the vector whose components are combinations of Bessel function, and the combination's view depends on the polarization of the incident radiation. The various types of high-order cylindric polarizations can be combined by equations 2. So we can using equations 2 and 1 can obtain various special cases. The radial polarizations at phi 0 equal to 0 and p more 0, so it's equation 3. The azimuthal polarizations at phi 0 equal to half p and p more 0 is equations 4. The quasi-radial polarizations at phi 0 equal to 0 and p less 0 is equations 5, and quasi-azimuthal polarizations at phi 0 equal to half p and p less 0 is equation 6. In this paper and in this speech, the main attentions on the focusing of cylindrical polarized first order beams by diffractionaxicons. The Gaussian beams with the corresponding polarizations from equations 3 to 6 considered as an incident beam. So, for example, about radial polarizations, you can see on the slide equation 7, where sigma is the radius of the Gaussian beam. On this slide, you can see the simulation parameters. For example, is the wavelengths, combination cell size, the thickness of the absorbing layer, the spatial sampling step, and the time step. C is the speed of the light. Cylindrical polarized Gaussian beams were considered as input laser radiations. The refractive index of the diffractionaxicons and substrate was 1.5. The numeric aperture of the focusing diffractionaxicons was 0.95. Some information about high-performance computer systems. For calculations, I used the free software package MIP. For axicons, I have exceeded more exact calculations using the finite difference time domain method, and I use cluster with these characteristics. You can see on the slide. For one task was used from 32 or 48 cores. On this slide, you can see the result of numerical simulations about focusing cylindrical-polarized beams by diffraction axicon in XZ plane. For radial polarizations, the for width at half maximum, for the total intensity of the electric field components outside the element was equal 0.55 lambda. For the intensity of the component Z is the intensity of the longitudinal component of the electric field was equal 0.53 lambda. The global maximum is inside the optical element, and its value for the total intensity and intensity of the electric field components, longitudinal components, was equal 0.38 lambda. Later, modeling was carried out for a more complex type of polarizations, which is also an unhomogeneous local linear polarizations. It's equal from its gradations from 8 to 11. Since none of this type of polarizations from gradations 8 to 11, the classical azimuthal polarizations with sharp focusing the longitudinal component of the electric field should appear. And this fact is confirmed by the studies on the next slide. On this slide you can see the result of numerical simulations, more complex type of polarizations in point bit I tell before about this. When we are analyzing the result, it was nothing that for radial polarizations the first maximum is formed inside the optical element, and the second maximum is outside it. But the focal spot is radar in this case. Expectantly about if we will tell about full width at half maximum equal 0.55 lambda, and full width half maximum equal 0.69 lambda. With not uniform local linear polarizations of the radial type, the formed terrain maximum is located outside the optical element. Also note that for all the considered heterogeneous local linear polarizations, a focal spot is formed on the optical axis, in contrast to the standard azimuthal, quasi-radial, quasi-azimuthal polarizations. Also for this type of polarizations, it was nothing the amplifications of the longitudinal component of the electric field. This slide presents the main conclusions. For example, the comparative simulations of diffraction of cylindrically polarized beams on a high-aperture DIFFRACTIONAXICON was investigated using the finite difference time domain method. The size of the focal spot equated by the half width at the half maximum intensity, and it's shown that with the considered unhomogeneous local linear polarizations of the radial and azimuthal types, it's possible to achieve a shift of the main maximum being on the limits of the optical element. For homogeneous local linear polarizations of the radial type, the focal spot is wider than for radial polarizations. For an unhomogeneous local linear polarizations of the azimuthal type, a focal spot is formed on the optical axis, and in contrast to the standard azimuthal polarization. Also for this type of polarization, it is worth nothing as a strengthening of the longitudinal component of the electric field. This work was financially supported by the Russian Foundation for Basic Research, grants you can see on the slide, and by the Ministry of the Science and Higher Education. Thank you for your attention.